In the quiet, endless expanse of the cosmos, countless galaxies drift in a silent cosmic ballet. For billions of years, this celestial dance has unfolded in serene majesty, a tapestry of light and shadow woven across the fabric of space-time. But this tranquility is an illusion. Hidden within this peaceful vista are forces of unimaginable violence, capable of unleashing destruction on a galactic scale. The universe is not always a gentle place. It is home to the most powerful explosions known to science, gamma-ray bursts. Deep within a distant galaxy, a star many times more massive than our own sun is nearing the end of its life. It has burned for millions of years, a brilliant beacon in the cosmic night. But now, its fuel is spent. The delicate balance between gravity pulling inward and the fiery fusion pushing outward has been broken. In a fraction of a second, gravity wins. The star's colossal core collapses under its own immense weight, imploding at nearly a quarter of the speed of light. The outer layers begin to fall inward, creating a shockwave of unimaginable force. This is the birth of a black hole, but it is also the trigger for something far more spectacular. From the heart of this stellar death, an explosion of pure energy erupts. Two hyper-focused jets of matter and radiation, narrower than the beam of a flashlight, tear through the collapsing star. They are launched into the cosmos at nearly the speed of light. These are the jets of a gamma-ray burst. For a fleeting moment, this single event outshines its entire host galaxy, releasing more energy in a few seconds than our sun will produce in its entire 10 billion-year lifetime. It is a cosmic lighthouse, briefly illuminating the universe with the most energetic form of light, gamma rays. The sheer scale of this energy is difficult to comprehend. Imagine 1 billion trillion suns all shining at once from a single point in the sky. That is the brilliance of a gamma-ray burst. These beams of death travel across the universe for millions, even billions of years, carrying a message of cosmic violence. They are invisible to the naked eye, a silent, deadly force traversing the interstellar void. Most are harmless, pointed away into the empty space between galaxies. But what if one of these beams were aimed directly at us? Let's imagine a gamma-ray burst originating from a relatively nearby star, say, a few thousand light-years away within our own Milky Way. What makes gamma-ray bursts so terrifying is their stealth. Because gamma rays travel at the speed of light, there is no advance warning. We wouldn't see the star explode first. The light from the explosion and the deadly radiation would arrive at the exact same moment. We would have no time to prepare, no time to seek shelter. It would be an instant global catastrophe delivered from the depths of space, a cosmic sniper shot with no muzzle flash. The first we would know of it is when the sky itself catches fire. This isn't just a theoretical scare story. Our telescopes have seen the afterglow of these incredible events in distant galaxies across the universe. In 1999, an event named GRB 9N0123 was observed. For nearly a minute, it was bright enough that, had it been closer, it would have been visible to the naked eye despite being billions of light-years away. In 2008, another burst, GRB 080319b, was so luminous it was nicknamed the Clark event, because it was briefly visible without a telescope from Earth, an astonishing feat for an object 7.5 billion light-years distant. Our scientific instruments allow us to study these events from a safe distance, piecing together the physics of stellar death and the formation of black holes. Each observation adds to our understanding of this violent, beautiful universe. Some scientists theorize that a mass extinction event on Earth hundreds of millions of years ago, the Ordovician-Silurian extinction, might have been caused by a gamma-ray burst. The evidence is circumstantial but compelling. A sudden die-off of marine species that lived near the water's surface, consistent with the destruction of the ozone layer and a subsequent flood of UV radiation. It is a chilling reminder that what happens in the cosmos does not always stay in the cosmos. We are part of this larger environment, and we are vulnerable to its whims. Fortunately, Earth is not defenseless. Our planet is wrapped in a protective cocoon, a powerful magnetic field, and a thick atmosphere. The magnetosphere deflects the majority of charged particles from space, including cosmic rays. The atmosphere acts as a physical shield, absorbing high-energy photons like X-rays and gamma rays long before they reach the surface. This dual-layered defense system is what makes life possible, constantly protecting us from the background radiation of space and the fury of our own sun. It is a testament to the remarkable resilience of our world. Even if a gamma-ray burst were to strike and inflict massive damage, life is tenacious. First, the progenitor star has to be a specific massive type that is relatively rare. Second, it has to be close enough for its radiation to be a threat. The jets are extremely narrow, so the chances of being in the crosshairs are astronomically low. Statistically, an event like this might happen in our galaxy only once every few million years, and the probability of it being pointed at Earth is even lower. We are more likely to be struck by a large asteroid. As we pull back and gaze upon the universe once more, we see it in a new light. The silent beauty of the night sky conceals forces that can erase worlds in an instant. This knowledge isn't meant to inspire fear, but to foster a profound sense of awe and humility. It underscores the incredible preciousness of our own world, this tiny, fragile oasis of life, protected by a thin layer of air and an invisible magnetic shield. We are adrift in a cosmic ocean, where celestial hurricanes of unimaginable power can rage. It's a reminder of our place in the universe, small, vulnerable, but also incredibly fortunate to exist at all. Thanks for joining us on this journey to the most violent corners of the universe.